Okay, everybody, here's a quick helper if you feel like you want one. So the whole idea of all of these problems is the same. It's the same high-level pattern. It's the Monte Carlo approach. And that approach involves performing a whole bunch of random experiments and recording the results, and then doing something with them. So if you're finding the probability of something happening, then you perform all the trials, you see if the result of your experiment is the condition that you're interested in finding the probability for, and if it is, you add to a counter. At the end, the probability is how many times the experiment turned out the way you were interested in, divided by the total number of trials that you performed. If you're trying to find the average value of something, it's a very similar pattern. You run a bunch of experiments, you record the information that you're interested in finding the average value for, you add those into a sum, and you divide by how many. So this high-level pattern is the right way to think about decomposing all of the problems. So the problems might look really different on the surface, but this is your starting point for breaking them into manageable pieces. So really, every single time, your code is going to have one of these two patterns, and the only thing that really needs to be different is how does it actually work to perform the random trial? So let's look at some examples. Okay, gambler's ruin. So a gambler makes a series of $1 bets, which she has a 50% chance of winning. If she wins, she gains $1. If she loses $1. She starts with $50 and continues to play until either she goes broke or has $250. So here's like a little picture of what that might look like. She starts with 50 and she wins some and she loses some, and eventually she plays until she wins, or she wins some and she loses some and eventually she plays until she loses. So it sounds like this is a description of a single experiment. That's the single trial. So what do we want to know? We want to know what are the chances that she will go home with $250. So that sounds like a probability. So we're going to run this simulation described in the first paragraph. We're going to run that simulation over and over and over again, and we're going to count how many times did she go home with 250 and how many times did she go home with 0. Then we could do that whole thing again, only this time we want to know how many bets on average should she expect to make before she's done playing. So again, it's the same kind of overall structure where we're running this simulation, but now we want to know a different question about it. We want to know how many times did she play until the simulation ended. Let's look at having children. So a couple beginning a family decide to keep having children until they have at least one boy and at least one girl. So in other words, as long as either they have 0 boys or 0 girls, they will continue to have children. So estimate the average number of children they'll have. So this description right here is the trial. That's the experiment. So I have a couple with 0 children to begin with. They keep having children until they have both a boy and a girl. And so then what do I want to know? I want to know the average number of children they expect to have. So in each experiment, I want to know how many children did it take before they had one of each. And so it's, again, the same kind of Monte Carlo pattern where first I write the pattern for finding the average, and then I say, what is the trial that I'm going to perform, and what information do I want to know? So let's write just sort of the beginning of the code for having children as our example here. So here's my main method from before. Oops. So wait, what's a good name for my method? What do I want to know? Average number of children. Okay, so if it's an average, I'll have it be a double. So average or expected children until both sexes. And I think that I said, right, P is the probability of having a boy, and N is the number of trials to use. All right, so I'm going to give it a value for probability of boy, and then num trials to use. All right, so let's create that method. And then I'm going to create I guess I'll create them here. So probability of boy, let's make it 50%. And instead of num trials, let's just use max trials, which is already a constant I've created. All right. so here we are. Why did this not create my method? Okay, here we go. So I've got expected children until both sexes. It's a double because it's an average. So I might expect to have like 3.8 children on average until I have one of both genders. Okay, so what's the pattern? So I'm thinking, all right, so don't think about the details of like, wait, we're having children until what, while? No. The high level thing that we want is we want to find an average. So whenever we're finding an average, we want a pattern where we have a bunch of trials. So trial num starts at 0. Trial num is less than max trials, trial num plus plus. And I want to run one trial. This is maybe not a very descriptive name, but I want to sort of emphasize what's the common pattern to all of these. So I'm going to run one trial, and it's going to tell me back what I want to know, which is how many children. So total children. So again, when I'm running one trial, we're having boys and girls until we have one of each, and what it tells me back is how many children did I have in total before that happened. And so I'm going to add that into the child sum. So child sum plus equals total children. So that means I need to create child sum up here. And then if I'm going to find an average, I'm going to return at the very end child sum divided by max trials. And then I have this panic response where I'm thinking, oh wait, is this integer division? And it certainly is. So I think I'll fix this problem by making this a double. Okay, great. So now I know it's going to give me an average if I can just write this part properly. So I'm going to rename this. I'm not going to call it run one trial. I'm going to call it have children until both sexes. And then you always have to think, like, what information does this process need in order to do its job? And this process is going to need the probability of having a boy. So I'm going to pass that information into the submethod. So probability of having a boy. Okay. All right, so now all I have to do is think, okay, how am I going to simulate that process of them having babies until they have one of both genders? And that's the part that I'll leave for you to implement, to kind of think about. I would advise using a while loop. But I hope that this helps you think about how you decompose the problem. You don't worry about the details of the simulation until first you think about, okay, I'm running the simulation a whole bunch of times to find an average, or I'm running the simulation a whole bunch of times to find a probability. So really, all the problems have the same overall structure here. The only thing that's different is the details about what simulation is getting run. Okay, I hope this was helpful. Good luck.